Redox chemistry, and I got some clicker questions at the end of this. So redox chemistry is important to us because it will help us have a common language when we talk about cellular respiration. And one of the most important things about cellular respiration is going to be the movement of electrons, and those electrons are going to be a storage of chemical potential energy. So we've got to understand about the movement of electrons and therefore the language we use to describe the movement of electrons between molecules or between atoms. Okay, so let's take a look at this slide here. We've got two molecules here, molecule A at the top there and molecule B down at the bottom. Now at the top you can see molecule A has got those two red balls associated with it with E minus in it, and those two red balls represent electrons. So those are electrons, and molecule A is going to give or donate those electrons to molecule B. And so you can see that as molecule A loses those electrons and gives them to B, B gains the electrons, and doing so now has two additional negative charges. So when A loses those electrons, it is said to become oxidized, and the process there is oxidation. And so in oxidation, compound A is losing electrons. So you can remember this using the word oil, or the abbreviated term oil. For oxidation involves loss of electrons. So A is being oxidized because it is losing electrons. Now B, in gaining electrons, is becoming reduced, and that process of gaining electrons is called reduction. You can remember that using the acronym RIG. Reduction involves gain of electrons. So you put those two together and you end up with this term oil rig. Oxidation involves loss of electrons and reduction involves gain of electrons. So if a molecule is being oxidized, then it is losing electrons. And if a molecule is being reduced, then it is gaining electrons. So that's the first layer of our discussion about redox chemistry. We can now think about what A and B are doing in the processes of oxidation and reduction. So let's go back to molecule A. When a molecule, such as A here, donates electrons to another molecule, such as B here, the molecule donating the electrons is said to be a reducing agent. An agent just means it's a molecule that's doing something here. So if it is giving electrons, then molecule A is the reducing agent. Now don't forget that the reducing agent in giving electrons will become oxidized. Now a molecule which takes electrons, pulls electrons from another molecule, the reducing agent, that is called the oxidizing agent. So in this diagram here, A is the reducing agent because it is reducing B. That is to say that it is giving electrons to B, and B is pulling electrons from A, and so B is the oxidizing agent. So we have to be very careful here about whether we're talking about oxidation, which is a process, whether a molecule has become oxidized, or whether we're talking about whether a molecule is a reducing or oxidizing agent. So we're going to be very careful not to mix up our verbs, adjectives, and nouns as we're talking about this. So that's a kind of quick overview, and you may need to come back to this slide as we start to review some of these clicker questions. So let's just kind of run through the clicker questions, and it's what we're going to do here is I will put the clicker question up, and I'll read through it, and I will pause briefly. At that point, you should probably pause the video so you can read and think about this in your own time as you need to, and then restart watching the video when you're comfortable that you've picked the right answer. So I'm going to read the question, pause for a couple of seconds, and that is your cue to pause the video, think about the question, and then when you're ready, click play again. So let's get going. During glycolysis, glucose loses electrons to a molecule called NAD+. What is happening to glucose? Okay, so I hope you paused the video there and had to think about the question. So glucose is losing electrons. And so remember, oxidation involves loss. So if glucose is losing electrons, it is being oxidized. B is the correct answer there. During glycolysis, glucose loses electrons to a molecule called NAD+. What is happening to NAD+ now? Okay, so NAD plus is gaining electrons. Remember, reduction involves gain. So here, NAD plus is gaining electrons, and so it is being reduced, A. A is the correct answer here. At the end of the electron transport chain, electrons are given to oxygen. What is happening to oxygen? So here, the electrons being given to oxygen, that means the oxygen is gaining the electrons. So think about this one. Okay, so oxygen is gaining the electrons, and so that means that oxygen is being reduced. Remember, reduction involves gain. The electrons are being given to oxygen, and oxygen is gaining the electrons, and so oxygen is being reduced. And incidentally, that leads to the production of water at the end of the electron transport chain. Here's the next one. At the end of the electron transport chain, electrons are given to oxygen. Just same things happened just now. What is happening to the molecule giving the electrons? So here we've got a molecule giving the electrons. So think about this giving action. Okay, so if a molecule is giving electrons, that means it itself is losing electrons, and oxidation involves loss of electrons. So the molecule that is giving is losing the electrons, and so the molecule giving the electrons here is being oxidized, B, being oxidized. Okay, so here we've got an equation which kind of is a more abstract way of thinking about this phenomena. A with an electron, that's A superscript E, A with an electron plus B is converted to A plus B with an electron, that's B superscript. So A with an electron plus B is converted to A plus B with an electron. Which term describes A? Okay, so here we've got A giving the electron to B. So A is giving the electron to B, and that means that A is reducing B. B is becoming reduced. A is becoming oxidized, but A itself is the reducing agent because it's giving electrons. So B. Okay, same scenario as before. A with an electron plus B is converted to A plus B with the electron from A. So what is happening to A? Okay, so A is losing its electron here and it's giving it to B. So in this case, A is being oxidized. So the answer is B. Oxidation involves loss of electrons, remember. A little bit more complicated. Your cells can take pyruvate and convert it to lactic acid if there's insufficient oxygen to allow the electron transport chain to run. You'll be familiar with this if you go and get on a treadmill, or you go outside and you run, or you lift weights really hard, or you skip really hard for a long time and you become anaerobic, you don't have enough oxygen. This is what happens, is that kind of early burn you get in your muscles is due to the initial accumulation of lactic acid. The later burn and the soreness you get is actually due to muscle damage to the fibers, but that initial kind of burn you get is due to the accumulation of lactic acid. So that process can be summarized as pyruvate plus NAD plus is converted to lactate plus NADH. Okay, so the core of the question here is how many reducing agents are there here? Okay, so is what we've got going on here is pyruvate is giving electrons to NAD+, and NAD+ is obtaining the electrons. Now the products from all that process is the production of lactate and NADH. So lactate and NADH aren't doing anything here. Nobody's acting as a reducing agent on that side of the equation. So we're going to look at the left side of the equation with the reactants. Those are the only things that can be doing anything, acting as an agent on this side. So pyruvate here is giving the electrons to NAD+. So that makes pyruvate a reducing agent. So there's one. Now the only other molecule on that side of the equation is NAD+. And NAD+ is receiving electrons. So that's an oxidizing agent. So there's only one reducing agent here. So that's one. The answer is A. Okay, so the same questions then. Your cells can take pyruvate and convert it to lactic acid if there's insufficient oxygen to allow the electron transport chain to run. This process can be summarized as pyruvate plus NAD plus converted to lactate plus NADH. The question is, which is more reduced? Which is more reduced? Okay, so Here we've got pyruvate giving electrons to NAD+. So NAD+ is going to become reduced. So in that sense, NAD+ is starting out in an oxidized state and is acting as an oxidizing agent, and it gains electrons to become reduced. So that means that NADH, having gained electrons from pyruvate, is more reduced than NAD+. So in these questions, you're looking for the molecules or molecule which have received electrons or which have the most electrons to surrender. Now, if I asked you about pyruvate versus lactate, then pyruvate is more reduced than lactate because pyruvate has got electrons to donate, which it's doing when it gives electrons to NAD+ to form NADH. So which is more reduced? NADH. B is the correct answer. Okay, now we're going to get a little bit more complicated. Now this is the kind of harder kind of question that you could get asked about redox on an exam. And this is using an example that you'd never encounter unless you took microbiology. But if you understand the principles of redox chemistry, you can solve this question by applying your understanding. So let's take a look at this one. It's a little bit harder. The diagram to the right is the Stickland reaction. This process is used by Clostridia as a way to make ATP. So what are Clostridia to start with? You don't have to know this, but it's just kind of nice to know. Clostridia is a genus of bacterium which includes Clostridium botulinum, for example. That causes botulism, which can result in forms of paralysis. And you've probably heard about Botox. Botox is a toxin which is obtained from Clostridium botulinum. And so these bacteria tend to live in anaerobic environments, in kind of like cans of hot dogs, for example, which have got rich sources of amino acids. So if we look at the reaction on the right, just to familiar ourselves with what's going on, is what's happening here is a fermentation of the amino acid alanine to acetate. So you don't have to understand what all these molecules are, as what we're looking for is the movement of the electrons. So let's look at the core of the question. How many molecules are being oxidized in the process? So remember, oxidation involves loss. Oxidation involves loss. So take a look at it. We'll be back in a moment. Okay, we're back. So how many molecules are being oxidized in the process? So oxidation involves loss, remember. So the question is, how many of the molecules in this diagram are losing electrons? So let's start at the top and on the left with alanine. Now alanine is giving some electrons here to NAD+ to make NADH, and you know that because NAD, when it becomes reduced, becomes NADH. So alanine is giving up electrons. Remember, oxidation involves loss. So alanine is being oxidized. So there's one. Then we've got pyruvate giving up electrons to NAD+ to make NADH. So pyruvate is being oxidized. Now let's look at acetyl-CoA there. Is acetyl-CoA giving up any electrons? And one of the easiest ways to see electrons being moved around is to follow the hydrogen atoms. And so when we see acetyl-CoA being converted to acetyl phosphate, there are no electrons being moved around, no hydrogens being added to NAD to make NADH. So there's no redox chemistry going on there. And the same is true for the conversion of acetyl phosphate to acetate. The formation of ADP, or the formation of ATP using ADP, is not a redox reaction. And so we've got two molecules so far. Let's go and have a look on the right-hand side. We've got glycine, and glycine is accepting electrons from NADH here. So glycine is becoming reduced, and we're looking for molecules that are being oxidized. So glycine isn't being oxidized. But what about this NADH here? Now, NADH is giving its electrons. It's losing electrons to glycine. So there we go. There's a third molecule. And that's all we got going on here. 3 molecules are being oxidized in this process. So the answer is C. Okay, we've got the same reaction here. Now, what word describes the role played by glycine? Okay, so in this reaction here, glycine is accepting electrons from NADH. So glycine is accepting electrons from NADH. So glycine is pulling electrons. It's pulling electrons from NADH. And NADH is giving the electrons. So the NADH in giving the electrons is the reducing agent. That means that Glycine must be the oxidizing agent. It is the molecule taking the electrons from NADH. So B, correct answer here is B. Okay, so a couple of pretty tough questions at the end there, but work through the clicker questions. And if you have any questions about the redox chemistry, get together with me or with Austin or with one of the LAs, and we can work through lots of different examples and break this down in some different ways. Let us know and we can help you, and you'll be able to answer these questions, these last two questions, which are a little bit more difficult, just by applying your understanding of redox chemistry. Okay, I will see you next time. Have a great day.